You there, Tina?
I'm here.
Yay.
Hello. Good
Hi.
to join you all. My name is Tina Mozelewski. I am currently a lead scientist at Conservation Science Partners. But before I joined CSP, I was lucky enough to do a postdoc with Tony Lin at University of Massachusetts Amherst, and then affiliated with the Northeast Climate Adaptation Science Center. So the work I'm going to talk about today is definitely not just mine. It was done with Tony Lin, it was done with Claudia, and with Kat Paulson, who is at Fish and Wildlife Service. So this is just kind of a summary of that. Okay, slide. All right, so I'm going to kick things off from the species perspective. So what you're looking at is the foothill yellow-legged frog, which is a stream obligate species. It's about the size of a silver dollar, and it gets its name because it has these characteristic yellow spots on the underside of its leg. Slide. So the foothill yellow-legged frog is found in California and in Oregon. It's predominantly found in streams and along stream edges, and it's kind of broken down into these two distinct regions. So you kind of have these coastal regions and then mountainous in the Sierra Nevadas, and within those regions they're broken down into clades. And so on this map here you can kind of see how you have these distinct clades of the foothill yellow-legged frog. And like so many things, historically was pretty commonly found throughout its range, but in the past 50 plus years has started experiencing pretty significant population declines. And these population declines are kind of coming from all different directions. So you have non-native species like bullfrog and cratefish that have really started heavily predating this frog species. There's also been an increase in chytrid fungus, which is causing pretty widespread mortality events. And then you have drought, which is reducing available habitat, along with things like stream alteration from dams and diversions, kind of throughout the watershed, that have really just resulted in widespread loss of habitat availability and habitat decline. And so what this has kind of resulted in is, of these clades, 5 of the 6 of them have been listed as threatened or endangered under the California Endangered Species Act, and then 4 distinct population segments have been recommended for listing under the Federal Endangered Species Act. And so I think the kicker is that a lot of these threats, both interactions with non-native species and then drought, are going to be exacerbated by climate change, right? So you're going to have, potential changes in interactions with these non-natives, but then you're also going to have drought, increasing stream temperatures, and then massive flood events that are really going to continue this habitat availability decline, and then potentially population declines at large. Slide. And so I think the management implications of this are pretty significant because of the population declines, and because it's becoming a listed species, and because it occurs on a lot of different federal land that's held by different federal landowners in California. There's a lot of interest in conservation for this species, but there's also a lot of interest in how to structure and where to structure that conservation. There's a bunch of different stream segments that you could possibly manage. And so thinking about where you prioritize your conservation has become a big topic of conversation. So managers from the Forest Service, from National Park Service, from California Department of Fish and Wildlife, along with scientists at USGS, have kind of all come together to say, okay, how do we kind of make smart investments in conservation in the future? And this is really stemming from kind of multiple use mandates, and just the fact that you can't invest in conservation everywhere you would maybe want to do it. And so thinking about how do we invest in places that are not the places that are unlikely to be suitable in like 5 or 10 years. Slide. So for this, we really focused on Stanislaus National Park and or Stanislaus National Forest and Yosemite National Park. Slide. And so what we did was map climate change refugia for this frog species. And so what you can see is you have 2040 on the left and 2080 on the right. And you can see that especially for some of these smaller tributaries, by the time you get to 2080, your populations or your suitable habitat, you start seeing declines in suitable habitat, especially in those tributaries. And so what these refugia can do, it's not telling you like, definitely do your management here, definitely don't do your management here. But it can kind of help you to do geospatial prioritization of your conservation. And so partnering with managers, we can give these maps, and it's not just handing over the maps, it's actually like these iterative conversations with them to say, okay, so, you know, this stream segment is projected to remain suitable habitat for a long time. Maybe this is where you prioritize your restoration, or maybe this is where you prioritize doing invasive species removal. Here's a stream segment that is maybe not suitable habitat now, but is going to be in the future. Maybe that's where you start thinking about in situ head starting. So it can help with thinking about where you want to manage, but also where, what, and when you want to do your conservation. Slide. And so that was the fastest version ever. But if you want more information, this is again linking to the Refugia Research Coalition site. And then there was also an article in Sierra Club magazine.
Thank you so much, Tina. And thanks for taking time out of your day job to be here today, your new day job.
Thanks.
And yes, so we've asked people to be sort of short on the details, but to focus really on the applications. If you want more info on the details, I'm sure everybody on the team would be happy to share more about their projects. And